Hello everyone. Today we will qualitatively analyze inorganic compounds. First of all, you will prepare the original solution. For that, you will dissolve the sample in cold water. If it is not dissolving in cold water, we'll heat the solution and we'll try to dissolve in hot water. If it is still not dissolving, follow the same procedure with HCl, then with nitric acid, and then with aqua regia. Normally, the sample that is given to us is soluble either in water or in HCl. Please note, the word cold and hot, they are very important. They are the keywords and it should be written. But the word cold doesn't mean it's going to be an ice cold solution. It actually means the water or the acids at room temperature. Next, we move to the test for group 0. For this, we're going to take the dry sample. You will add few drops of sodium hydroxide solution in it and you will heat. If you get a pungent smelling gas, it indicates the presence of group 0. And if that gas turns Nestle's reagent brown or it produces a dense white fumes when it comes in contact with concentrated HCl, it indicates the presence of ammonium ion. Please note the two. One is confirming group 0 and the second one is confirming ammonium plus ion. Moving to group analysis. All total we are having 6 groups. In the first group we are having lead 2 plus ion. In second group we have lead 2 plus ion and Cu2 plus ion. Lead is the only ion which is present in group 1 as well as in group 2. In group 3 we have ferric ion, we have aluminium ion. In group 4 zinc, cobalt, nickel and manganese ion is present. In group 5 barium, strontium and calcium is present, and in group 6 we have magnesium. Moving to group 1. In the original solution, first of all you will add dilute HCl. If you get a white precipitation, it will indicate the presence of group 1. You will stop your procedure if it is present, otherwise you will add H2S. After adding H2S, if you get a black color precipitation, it indicates the presence of group 2. If not, first of all heat the solution and boil of H2S. For this you can use the lead acetate paper to test whether the H2S is gone or not. Then you will add few drops of concentrated nitric acid and you will reheat it. Then you will add ammonium chloride followed by ammonium hydroxide till ammoniacal. This order is very important. If you get a precipitation, it indicates the presence of group 3. Moving to group 4, it will pass H2S gas to the above solution. If you get a precipitation, it indicates the presence of group 4. Otherwise, switch to the next one. Boil off H2S and heat it further so that the mass turns 1/3 of the initial. Then you will add saturated ammonium carbonate solution. If you get a white PPT, it will indicate the presence of group 5. If not, add disodium hydrogen phosphate solution in it, and if you get a crystalline white PPT, it indicates the presence of group 6 as well as magnesium ion. Remember, magnesium is the only ion which is analyzed directly in the group analysis table. For this you don't need to write separately. This is the chart which you can follow, or you can write in the form of experiment, observation as well as inference. Moving to the confirmatory test for the basic radicals. The group 1 precipitation that you have got, white color group 1 precipitation, you will try to dissolve that one in hot water and then you will add potassium chromate solution. If you get a yellow color precipitation, it indicates the presence of lead ion. The black color residue that you have got in group 2, you will dissolve that one in nitric acid and you will divide that one into 2 halves. In the first half, you will add potassium chromate solution. If you get a heavy yellow precipitation, it indicates the presence of lead ion. In the second part, you will add potassium ferrocyanide solution. If you get a chocolate brown precipitation, it indicates the presence of group 2. Now please note, if lead ion is present, it will respond to group 1 as well as group 2. If you are getting group 1 positive, no need of proceeding to group 2. But if you have copper, group 1 will be negative and group 2 will be positive. In group 3, take the precipitation, add concentrated HCl and dissolve it. In the first part, add little bit, hardly 2 to 3 drops of sodium hydroxide. You will get a gelatinous white precipitation, which will indicate the presence of aluminium ion. If you add extra amount of sodium hydroxide, that gelatinous white precipitation will dissolve. I repeat, if you add extra, then it will dissolve. So when you are adding sodium hydroxide solution, please be careful. In the second part, we will add potassium ferrocyanide solution And if you get a Prussian blue coloration, it indicates the presence of ferric ion. Moving to group 4. The precipitation that you have got, dissolve that one in concentrated HCl and add few drops of potassium ferrocyanide. If you get a bluish white precipitation, it indicates the presence of zinc ion. Moving to group 5. The residue of group 5 is washed properly with water and then it is dried in the filter paper itself. Then we will carry out the flame test. For this flame test, first of all, the platinum wire is taken, it is rinsed properly in concentrated HCl, and then a bit of the sample is taken with the platinum wire, which is initially you have dipped it in HCl, and which means you have soaked it in HCl, and place it in the Bunsen flame. If you get an apple green coloration, it indicates the presence of barium ion. If you get crimson coloration, crimson red color, it indicates the presence of strontium ion. If you get a brick red coloration, it indicates the presence of calcium ion. Instead of this platinum wire test, you can also carry out BSC method. Now in this BSC method, this order is very important. First of all, we'll test barium, then strontium, and then calcium. So what we'll do, first of all, the residue of group 5 is dissolved in acetic acid. Then we will add potassium chromate solution. If you get yellow PPT, it indicates the presence of barium ion, you will not proceed further. If not, then only you will add ammonium sulfate solution. If you get a white PPT, it indicates the presence of strontium ion, stop over there. Otherwise, add potassium oxalate solution and you will get definitely will get a white color precipitation indicating the presence of calcium ion. Moving to pre-lead test for anions. Remember, these are the pre-lead tests, these are not the confirmatory test. So you will take the dry sample and you will add dilute sulfuric acid in it. If you get a colorless, odorless gas, it indicates the presence of carbonate ion. Remember, carbonate ion may be present, but it's not a confirmatory one. You have to pass the gas through lime water, then only you will be confirming it. If you get a colorless gas, but it is having a choking smell of burning sulfur and it is turning acidified potassium dichromate paper green, it indicates the presence of sulfite ion. Remember, sulfite ion may be present. Otherwise, if you get a rotten smelling gas and it is turning lead acetate paper black, sulfite ion may be present. Remember, these are all the pre-lead tests. They are not the confirmatory test. This will provide you just a basic idea. Next, take a small bit of the sample and add concentrated H2SO4 in it and heat it. If you get a reddish brown gas, nitrate ion may be present. And if you get the same reddish brown gas after adding copper turnings, nitrate ion may be present. Moving to the next one, confirmatory test for the carbonate ion. See, initially you have done the pre-lead test. When you have taken that sample, you have taken the sample and you have added dilute H2SO4 in it, but remember, don't heat it. If you get effervescence, pass that gas to lime water. If it turns milky, carbonate ion is confirmed. Remember, carbonate is the only ion, which is the only anion which is confirmed in dry test. The rest are done with the help of sodium carbonate extract. Moving to the preparation of sodium carbonate extract. You will take dry sample and anhydrous sodium carbonate in the ratio of 1:3. You will dissolve that one in 20 ml of water and you will heat it for 10 to 15 minutes. You have to filter it hot, and with the filtrate you have to carry out the following confirmatory test for acid radicals. First of all, take a small bit amount of the sodium carbonate extract and add few drops of sodium nitroprusside. If you get a violet coloration, it indicates the presence of sulfide ion. In the next set, first of all, in the sodium carbonate extract, you will add dilute HCl till effervescence ceases. Remember, there should not be any effervescence further. Then you will add barium chloride solution. If you get a white precipitation and that white precipitation is dissolving in HCl, it indicates the presence of sulfide ion. If you get a white precipitation which is insoluble in HCl, it will indicate the presence of sulfate ion. Moving to the test for halides. First of all, we will take the sodium carbonate extract. You will neutralize this one with dilute nitric acid. Be careful, dilute nitric acid till the effervescence ceases. Then you will add silver nitrate solution. If you get a white PPT which is dissolving in ammonium hydroxide solution, it indicates the presence of chloride ion. If you get a pale yellow color precipitation which is dissolving excess of ammonium hydroxide solution, it will indicate the presence of bromide ion. If you get a yellow color precipitation which is totally insoluble in ammonium hydroxide solution, it will indicate the presence of iodide ion. Moving to the test for nitrates and nitrate ion. First of all, this is actually the ring test. First of all, you will take a small amount of sodium carbonate extract. You will neutralize this one with H2SO4 till all the effervescence ceases. Then you will carefully add freshly prepared ferrous sulfate solution. You will cool it under running tap water, and then you will add concentrated H2SO4 along the side of the test tube. Please don't add drop wise, it may break the ring. If nitrate ion is present, you will get a prominent ring at the junction of the two liquids. If nitrite ion is present, the entire solution will turn brown. Moving to the test for acetate ion. First of all, you will take a small amount of sodium carbonate extract. You will add dilute HCl to neutralize it, and then you will add neutral ferric chloride solution. If you get a wine red coloration, it indicates the presence of acetate ion. Now for acetate ion, there is another test. For this, you have to take the dried sample, you have to add few drops of ethanol and concentrated H2SO4, and you will heat it. If you get a fruity smell, that also indicates the presence of acetate ion. Moving to oxalate ion. First of all, you will take the sodium carbonate extract. You will neutralize this one by dilute HCl. After neutralizing, you will add saturated calcium chloride solution. If you get a crystalline white PPT, it indicates the presence of oxalate ion. Now these are something that which is a basic principle. Now the question is, what actually you will do in the lab? As you enter the lab, first of all, make up this, arrange the setup for preparation of sodium carbonate extract. In the meantime, you will confirm whether group 0 is present or not. If group 0 is present, no need of doing any further cations because it is the only cation present. If you don't have, then start with the group analysis. As you get any precipitation in any of the group, stop over there and confirm which cation is there. You will not carry out any further cations test. Then you will carry out the pre-lead test for the anions. From the pre-lead test, you will get some idea that which ion is present, and then confirm that ion only. Now this is something that you will write. Remember, what you are writing, that is very important because that will be evaluated. So first of all, you will write the preparation of original solution. Then you will write the test for group 0. After that, you will write group analysis table. Now you will write the group analysis table till the group you will get the observation. Suppose you're getting till group 3, you will stop at group 3. You will not write group 4, 5 and 6. Is that clear? Moving to next one. You will write the confirmatory test of the respective cation. Then you will write the preparation of sodium carbonate extract and the confirmatory test of the anions. Please note, you will not write the pre-lead test of the anions. So dear viewers, if you really like it, please like, share and subscribe to my channel. Thank you.